The 3D printing process builds a three-dimensional object from a computer-aided design (CAD) model, usually by successively adding material layer by layer, which is why it is also called additive manufacturing. The term 3D printing covers a variety of processes in which material is joined or solidified under computer control to create a three-dimensional object, with the material being added together, such as liquid molecules or powder grains being fused together, typically layer by layer. In the 1990s, 3D printing techniques were considered suitable only for the production of functional or aesthetic prototypes, and a more appropriate term for it was rapid prototyping. As of 2019, the precision, repeatability, and material range have increased to the point that some 3D printing processes are considered viable as an industrial production technology, whereby the term additive manufacturing can be used synonymously with 3D printing. One of the key advantages of 3D printing is the ability to produce very complex shapes or geometries, including hollow parts or parts with internal truss structures to reduce weight, and a prerequisite for producing any 3D printed part as a digital 3D model or a CAD file. The most commonly used 3D printing process, 46% as of 2018, is a material extrusion technique called fused deposition modeling (FDM). While FDM technology was invented after the other two most popular technologies, stereolithography (SLA) and selective laser sintering (SLS), FDM is typically the most inexpensive of the three by a large margin, which lends to the popularity of the process. There are many different branded 3D printing processes that can be grouped into 7 categories: vat photopolymerization, material jetting, binder jetting, powder bed fusion, material extrusion, directed energy deposition, sheet lamination. In the current scenario, 3D printing or additive manufacturing has been used in manufacturing, medical, industrial, and sociocultural sectors, which facilitate 3D printing or additive manufacturing to become successful commercial technology. More recently, 3D printing has also been used in the humanitarian and development sector to produce a range of medical items, prosthetics, spares, and repairs. The earliest application of additive manufacturing was on the toolroom end of the manufacturing spectrum. For example, rapid prototyping was one of the earliest additive variants, and its mission was to reduce the lead time and cost of developing prototypes of new parts and devices, which was earlier only done with subtractive toolroom methods such as CNC milling, turning, and precision grinding. In the 2010s, additive manufacturing entered production to a much greater extent. Additive manufacturing of food is being developed by squeezing out food, layer by layer, into three-dimensional objects. A large variety of foods are appropriate candidates, such as chocolate and candy, and flat foods such as crackers, pasta, and pizza. NASA is looking into the technology in order to create 3D printed food to limit food waste and to make food that is designed to fit an astronaut's dietary needs. In 2018, Italian bioengineer Giuseppe Schonti developed a technology allowing to generate fibrous plant-based meat analogs using a custom 3D bioprinter, mimicking meat texture and nutritional values. 3D printing has entered the world of clothing, with fashion designers experimenting with 3D printed bikinis, shoes, and dresses. In commercial production, Nike is using 3D printing to prototype and manufacture the 2012 Vapor Laser Talon football shoe for players of American football, and New Balance is 3D manufacturing custom-fit shoes for athletes. 3D printing has come to the point where companies are printing consumer-grade eyewear with on-demand custom fit and styling, although they cannot print the lenses. On-demand customization of glasses is possible with rapid prototyping. 3D printing will have a significant value for fashion companies down the road, especially if it transforms into a print-it-yourself tool for shoppers. There's a real sense that this is not going to happen anytime soon, but it will happen, and it will create a dramatic change in how we think both about intellectual property and how things are in the supply chain. Please subscribe and click bell icon for upcoming videos.